operation. Okay. Let's see how to update. There are two ways to update the dynamic routing protocol. A cycle update. A trigger update. Periodic update. I still use OSPF as an example, because EIGRP has no periodic updates. So I can only use OSPF as an example. This is R1. This is R2. Two devices. A PC is connected here. This is also connected to a PC. There is a line between them. Another dynamic routing protocol is running between the two devices, called OSPF. You don't care how it works. The two of them can now interact with data. For example, there is a segment here, 1.0. There is also a segment here, 2.0. They have learned from each other. R2 can go to 1.0. R1 can also go to 2.0. After learning, it is equivalent to the stable operation of the routing protocol. The message is all over. They also periodically send messages to each other's devices. Send your own routing entries. OSPF is 30 minutes. Because it is necessary to make sure that the overall information is consistent now. This is called periodic update. Periodically send your own route to the other party. But we have a problem here. If now in the entire network environment, only periodic update. For example, at some point, a 3.0 network segment came to R1. Then 30 minutes later, R1 only told R2 the network segment of 3.0. This is too slow. Added this network segment from R1. Until R2 can finally identify and learn this network segment. 30 minutes passed. After so long, I might as well enter a static route. So say you will find 30 minutes is unbearable. Certainly. I just give an example. You should know. 30 minutes is too long. So OSPF is definitely not like this. If it is like this, this deal doesn't work at all. So in addition to periodic updates, it also has a way to update. Trigger update. Parallel between the two. Trigger update is OSPF will periodically send messages to other devices. Of course, it is not sent directly to the device. It uses a multicast method. Other devices will receive messages periodically. It is a triggered update. As long as there is an extra network segment on it now, it will tell other devices that there is an extra network segment on it. Besides, it will be updated periodically every 30 minutes. This is what we're talking about as a parallel between the two. EIGRP is not used much. It has a constraint. It is a proprietary protocol of Cisco. Publicized in 2013. Public ownership means that others can use it. But it costs money to use. So we don't. This is one. Secondly, spending money is not a buyout system. Is a subscription. That is, we can't use this protocol forever. Have to buy a few years. Equivalent to buying authorization. This agreement is excellent. But because it costs money. So we don't. Before it was made public. If you want to use this protocol, all must be Cisco equipment. That is, your networking environment cannot have equipment from other companies, because other devices do not support. So it didn't hit the market at all. Very low occupancy. Very good technology. But no one used. It's really a pity. But we learned Cisco. EIGRP must learn its mechanism. Although it is not used much now. You hardly ever see EIGRP on projects. But don't give up your interest in learning it. These are the two update methods of OSPF. Then for EIGRP, only triggered updates. No periodic updates. Because in fact, there is no need for periodic updates. In addition, when at some point this network segment disappears, the device will immediately tell other devices that its network segment has disappeared. Other devices quickly delete the information about this network segment in the intersection table. Don't visit it anymore, because its network segment is gone. This is called trigger update. Triggers real-time updates of updated assurance information. Periodic update ensures the overall information interaction of the routing table. OSPF is once every 30 minutes. Ensure absolute synchronization of information between devices. Here are some differences between the two update methods. But these two update methods, not every routing protocol has. Just like EIGRP only triggers updates, while OSPF has both. Look at the specific agreement mechanism. Next, let's learn about the types of dynamic routing protocols. From the point of view of the current algorithm, there are two. One is the distance vector. One is the link state. Then tell everyone. We're going to talk about EIGRP. What kind of agreement is EIGRP? It belongs to the distance vector. It is updated in real time. It is a distance vector routing protocol. But it is a distance vector protocol with link state features. It has some characteristics of link state. It borrows some mechanisms in the link state. Because the development process of EIGRP refers to some public protocol factors. So it has both link state and distance vector. But in the end it's a distance vector protocol. Because when we judge the type of dynamic routing protocol, the specific thing is that it is interacting with the routing table or link state information. EIGRP interacts with the routing table. So it's essentially a distance vector protocol. But it has some characteristics of link state. Let's start with an older protocol called RIP. We won't talk about RIP in the course because it's been outdated for too long. Can simply mention. But there is no need to talk about its configuration. Suppose now there are 3 devices. This is 1. This is 2. This is 3. Connect with each other. Let's say there is a network segment here. 1.0 network segment. Then I now want 3 devices running RIP. First of all, you need to know. It is a dynamic routing protocol. It is characterized by. For device 1. It wants to pass this 1.0 network segment. Then first it will learn its own direct route. In addition to the 1.0 network segment. As long as it is directly connected to the network segment, it will learn. Then form a routing table locally. It will pass this table to its neighbor device 2. Device 2 will first accept this table. After accepting, calculate from your own table. Because between them, there may be some directly connected network segments. Device 1 also passed it. It has to calculate to see which local ones don't. The 2 of them are now connected to a device in the middle. For this device, there may be a network segment behind. It also gives device 1 the. It also gives device 2 the. Then device 1 gives device 2 again. For device 2, you have to do the math to see if you have one. Discard it if it has. Combine with device 1 if it doesn't. Then it will generate a new routing table locally. Then pass this new table to device 3. Device 3